In this video, we'll see several examples of how to use the basic derivative rules to find the derivative of some simple functions. Our first derivative rule is the power rule. That says if your function looks like x to any power, x to the k, then the derivative is k times x to the k minus 1. So you bring this power down, and then you subtract 1 from the original power. Okay, let's do a few examples. So the derivative of x to the fifth is just going to be 5 times x to the fourth. We brought down the 5 and then subtracted 1 from 5 to get 4. For the function y equals x, we can think of that as x to the first power, and that means that our derivative y prime is going to be 1 times x to the 0. But anything to the 0 power is 1, so the derivative here is simply 1. Finally, for our third example, the derivative of x to the minus 4 is going to be minus 4 times x to the, okay, so we have to be careful here. Subtract 1 from negative 4 minus 1, that's negative 4 times x to the minus 5. A common mistake here is to think that it's x to the minus 3, but we want to subtract 1, and when we subtract 1 from negative 4, we get negative 5. Another basic rule here is the constant rule that says the derivative of any constant function is 0. So if you were looking at the constant function y equals 17, the derivative is 0. This is not to be confused with the constant multiple rule, which says that if you have a constant times a function, the derivative is the constant times the derivative of the function. Again, let's see some examples here. So if we have y equals 7 times x to the fourth, the derivative is going to be 7 times the derivative of x to the fourth, which is 4 times x to the third, using the power rule. 7 times 4 is 28, so our derivative is 28x to the fourth. For the second example, the derivative of negative 9x is negative 9 times the derivative of x. If you remember from an earlier example, the derivative of x is just the number 1, and so our derivative here is negative 9. Finally, for this third example, it looks like a fraction. We're not exactly sure what to do with that. But what we can do is break this fraction up into two separate fractions, 1/5 times 1 over x squared, and realize that we can rewrite 1 over x squared as x to the negative 2. So 1/5 is my constant. The derivative of x to the negative 2 is negative 2 times x to the negative 3. And so my final answer here is negative 2/5 times x to the minus 3. One more rule here, which is sometimes called the sum difference rule. You'll often see this as two separate rules, but I'm combining it here as one rule, which simply says that the sum or difference of two functions, the derivative of that, is the sum or difference of the derivatives. Once again, we'll see a few examples. So if I have y equals 5x cubed minus 7, I simply need to find the derivative of 5x cubed and the derivative of 7, and then subtract them, and that will be the derivative of the whole thing. So my y prime here, the derivative of 5x cubed is 5 times 3x squared, minus, and the derivative of 7 is a constant, so the derivative of 7 is 0. So my answer is 15x squared. Here's another example. We've got three functions here, but the sum and difference rule still works the same. We just need to find our three derivatives separately, and then combine the answers, and that will be what we get. So my a prime of x here, the derivative of 24x is 24 times the derivative of x. The derivative of x is 1. What about the square root of x? Well, we can think of the square root of x as x to the 1/2, and then we can use our power rule. So the derivative of x to the 1/2 is going to be 1/2 times x to the, well, we subtract 1 from 1/2, and that gives us negative 1/2. And then finally, for 5 over x, we can rewrite that as 5 times x to the minus 1. And the derivative of 5 times x to the minus 1 is going to be 5 times negative 1, x to the minus 2. Let's clean this up a little bit. We've got 24 times 1, that's 24, minus 1/2 x to the minus 1/2. 5 times negative 1 is minus 5, times x to the minus 2. Finally, let's do one more example. Here we've got 3x plus 2 quantity squared, and none of the rules that we have so far let us deal with that squared in parentheses. So what we can do is rewrite our function, g of x, by simply writing this as 3x plus 2 times 3x plus 2. When we work that out, we get 9x squared plus 12x plus 4. And now this function's in a form where we can take the derivative. Very often with derivatives, you have to rewrite the function somehow, either by breaking up a fraction or multiplying something through, to get it into a form where you can apply our rules. In this case, the derivative is going to be 9 times the derivative of x squared, which is 2x to the first, plus 12 times the derivative of x, which is 1, and then the derivative of 4 is 0. 9 times 2 is 18, 12 times 1 is 12, so our final answer is 18x plus 12.